Hey guys and gals, welcome back. This is Notes with Griff. This is 4-3 Notes. We're continuing our discussion of calorimetry. Last time we talked about calorimetry or specific heat calculations. Today we're going to spend a little more time talking about calorimetry. And we're going to start with making a calorimeter. So to make a calorimeter, we need some very simple things. We need a styrofoam cup, a thermometer, and like I said, a lid if you're fancy. Not very many people actually use the lid, but you're welcome to use the lid if you want to. So in the lab, very simply, basically all you do is you check the temperature change, how much it went up or went down, and that tells you our temperature change, and then we just use the formula Q equals MC delta T to do our calculation. So it's the formula we learned yesterday in class. If it's a solid, usually our solid is dropped in water and the temperature change is measured. This will give you the energy absorbed by the water, which in turn can be the energy released by the solid, because remember, according to the law of conservation of energy, energy is transferred. It is never created or destroyed. So we're going to keep that in mind as we do the following examples. It's pretty simple. So our first example there, and these two examples kind of go together. So let's read through it and see what we got. A heated metal is placed in a calorimeter with 500 grams of water. The water's temperature rose from 20 degrees C to 25 degrees C. What is the heat energy absorbed by the water? So if we go through and do our highlighting, we have 500 grams of water. We have a temperature of 20 to 25. And we're looking for heat energy, or Q. So let's use our formula Q equals MC delta T. Q is our heat, that's what we're looking for. M is our mass, and that is 500. 500 grams. C is our specific heat. And we're talking about water, so our specific heat of water is 4.18. Sometimes 4, depending on what you're looking at, joules per gram degrees C. Delta T is our change in temperature. So we'll take final temperature minus initial temperature. But let's go ahead and write that in there. T final minus T initial. And we're going to take our final temperature, 25 minus 20. So we get 5. All right, degrees C. And so we're ready to now just plug it all in and solve. And this one we're looking for Q, so we don't have to do any rearranging. So we're going to take 500 times the specific heat, which is 4.184, times our temperature change, which is 5. And that will give us 10,000. Q is 10,460 joules. So that's the amount of energy that the water absorbed. Notice it's positive, and so thus that is what it's being absorbed. If we look at the second part of this question, it says, meanwhile, the metal's temperature dropped from 100 degrees to 25 degrees Celsius. The metal's mass is 592.9. What is the metal's specific heat? So if we go back to our formula, Q equals MC delta T. We've got a temperature change right here from 100 to 25. We have a mass, 592.5, and we're looking for specific heat. So at this point, what we need to know is that heat lost by the metal is absorbed by the water. So I'm going to write a little relationship right here. Q of metal is equal to negative Q of the water. So if I know the water is 1046 or 10460, that means the metal is going to be negative 10460. And that's joules. All right. M is our mass, and that's going to be 592.9. And that's grams. C is our specific heat. That's what we're looking for. Delta T is our temperature change. T final minus T initial. The metal went from 100 to 25, so it will be 25 minus 100, which gives us 75 degrees C. All right, so our next job is, let's go ahead and rearrange and try to figure out, we're looking for C, so we're isolating C, so I'm going to put M delta T on bottom to get those things to cancel. And I'm going to move that over the other side too, M delta T. So C is equal to Q over M delta T. And we've got Q, which is negative 10,460 over, I'm going to raise this up just a little bit so I have a little more space to write. We've got our mass, which is 592.9. And our change in temp is negative 75 degrees C. Didn't put that negative on earlier. So to calculate this, we're going to take negative 10,460 divided by 592.9 and also divided by 75, negative 75. Our specific heat of our metal is going to be 0.235, and that's joules per gram degree C. All right, thanks. See you next time.